Navodaya Vidyalaya.
Navodaya Nalgonda. Very good. So nice meeting you. So this is a physics department which we have entered. So in this we have one lab that is related to heat and acoustics. Okay. Acoustics means a study of sound. Okay. So and heat means heat, you know very well. Okay. So this lab is meant for studying the properties of heat and sound. Okay. So here this experiment which you are seeing is related to sound experiment. Okay. So in this produces ultrasonic sound. Do you know what are the types of sounds? Sounds: audible sound, infrasonic sound, ultrasonic sound. Are you in which class?
11.
Huh? 11. So you must be knowing. So if you are in 11th, you should know what are the sound types. Different types depending on the frequency. The sound is divided into 3: infrasonic, audible, and ultrasonic. So what is the frequency of ultrasonic sound? Frequency of ultrasonic sound. Don't you know? What is the audible sound range? 20 hertz to 20 kilohertz, right? So above 20 kilohertz is the ultrasonic sound. Below 20 hertz is the infrasonic sound. In between, audible sound. Okay? So what is our frequency here? More than 20 kilohertz frequency. So by which, by producing the ultrasonic sound, we are sending into a liquid like that. Okay? There, this column. You see that? So if ultrasonic sound is produced at the bottom by using a piezoelectric crystal, okay, which produces sound. Okay, and the sound waves will pass into the liquid column. This is a liquid column. Actually, this is a liquid column. You can pour some liquid into it and then press it here and close this. Okay. So here there is a reflector. Okay. So the produced sound from here, there is a piezoelectric crystal, and this produces sound and sends into the liquid column, and here there is a reflector. The sound gets reflected back and it produces stationary waves like that. So if the stationary waves are produced, you have nodes and antinodes, right? So which one is antinode, which one is node? The bulged one is antinode. Node is the sharper one. Okay? This is node, this is antinode. This one is antinode. This one is antinode. This one is antinode. Node, right? So here, this is the bottom at which you have seen the crystal. Crystal produces waves, and waves gets reflected back by this. Because of the reflection, both superposition of the two incident and reflected waves produces nodes and antinodes, causes stationary waves, right? So by knowing the wavelength, by measuring the wavelength, the length between the two nodes or two antinodes, we can calculate the wavelength of sound. Wavelength of sound. What is the wave here? What is the one wave? One wave is from here to here. One wave is from here to here, and it is getting reflected back. Okay. So this is the wavelength. Two nodes forms one wavelength. Okay. Two nodes. Distance between two nodes. Distance between between 1, 2, 3. This one. The distance between two antinodes and nodes is one wavelength, right? So that one wavelength gives you, by knowing the wavelength, you can calculate the velocity. velocity of sound. There you have velocity of sound V is equal to n lambda. V is equal to n lambda. N is frequency. Frequency of sound is here 2 megahertz. 2 megahertz sound is produced here. So by knowing frequency and the wavelength from that, then you can find out the velocity. Velocity in the liquid. So రాసుకున్నారా మీరు? V is equal to n lambda. N అంటే frequency. Frequency 2 megahertz. Megahertz అంటే 10 to the power of 6. 2 into 10 to the power of 6 into wavelength. ఆ wavelength ఎంత ఉందో క్యాల్కులేట్ చేస్తాం దీంతో. ఇది మైక్రోమీటర్ అన్నమాట. By knowing the wavelength, by moving this, okay, we can find out the wavelength. క్లియర్గా మీరు అంటే ఎక్స్పెరిమెంట్ చేస్తే దీన్ని మూవ్ చేస్తూ ఉంటే ఏమవుతుందంటే అక్కడ కరెంట్ మ్యాక్సిమం మినిమం ప్రొడ్యూస్ అవుతుంది. మ్యాక్సిమం వచ్చిన దగ్గర